Okay, gentlemen, I want you to turn off your mobiles and keep your mobiles in the pockets. Keep your mobiles in the pockets throughout the class. For your full name, look at the screen. Ahmed Abbas. Bender Sultan. Muhammad Mustafa. Muhammad Ahmed. Hussein Jafar. Saud Fahad. Abdullah Suleiman. Saud Abdul Aziz. Salman Fahad. Muhammad Ahmed. Salman Abdullah. Faisal Fahad. Muhammad Abdullah. We'll continue. No or yes? Abdurrahman Adil.
Yes.
Fahad Khalid. Muhammad Suleiman. Muhammad Ahmed. Hamid.
Yes.
Muhammad Haytham.
Yes.
Adib Farooq. Ibrahim.
Yes.
Yusuf. Hussein Abdul.
Yes.
Hassan Ahmed. Abdul Hadi. Ahmed. Jawad.
Yes.
Ahmed Mirza.
Yes.
Abdul Aziz. Ahmed Assam.
Yes.
Mishal. Saad Ahmed. Fahad Saeed. Abdul Aziz. Yes. Number? Anyone else who came during the attendance? Number?
Okay.
14. Anyone else? Okay, who's vigilant in making Google polls or Microsoft polls? Okay, by the end of the class, 10 minutes before the class ends, remind me. I will stop and I want you to make a Google poll for the date of exam. Okay. It must be week 7. So if all of you agree, by all of you, I mean 34 of you. If you agree on a single date and a single time, khalas, it's okay for me. If one of you don't agree on a single date or one of you disagree, then I will give you the date, I will give you the time, you have to agree on that. That's what I'm going to tell him to discuss. Yes, I'll give you the options and you can discuss. Second major 13. Week 13. Today, inshallah, we'll finish this chapter 2. And from next class, inshallah, I will start the long-awaited matrices. Plus, you have time until 4th of November. Recording is on. Now, in the previous class, let me review the things. In the first class of this course, we defined this model. And we said this is the equation of the point. Right? Then we took the mean of this equation for each level of x, and that we denoted as mu of y given x, any x, and this was beta naught plus beta 1 xi, and this is the equation of the line. And these are the two objectives of the chapter: to estimate the equation of the point or to estimate the equation of the line. Now, we did all the derivations and we came up with an estimated form for the equation of the line, and that was mu hat of y given x, and that was beta naught hat plus beta 1 hat times x naught. True? This is an estimate of estimated equation of the line. And we gave an argument that we don't have an additional information about the point. So we say that the point estimate for a single value is the same as the point estimate of the average value. And we said that this is also the same. The point estimates, we said they are same. Logically, they are same. Mathematically, they are equal. Logically, they have different interpretations. Like for the first one, let's say my example is, what is the example that we're taking? The propellant. Yes, the age of the propellant and the, what's the strength of the propellant. So for the first one, let's say I will interpret that for all the propellants which are 15 weeks old, the estimated mean strength is this. Whatever number comes out after plugging into the value, whatever number comes out, you will say for all the 15 weeks old propellants, the estimated mean strength is this. And the same number you can interpret in terms of a single point as for our propellant. For our propellant, single propellant, we predict that the strength will be this much if the age is 15. So the point estimates, we said they are same for both equations. Now, for the first equation, we derived an interval estimate, and that interval estimate was what? That was mu hat of y plus minus a critical value from the t multiplied by the square root of the standard error. This is what we derived in the previous class, and I think we applied this one in the previous class also on Excel. Any question up to this point? Today, I'll extend this idea to making a prediction interval for this one. Yes. The mu and the y naught. Again, the same example. If I tell you historically stat 310, the average score has been 71%. And I ask you to estimate this year, what will be the average of the class? What will be your estimate? 71%. And if I tell you not the class, I want the estimate for a single student and you don't know nothing about that student. Single student, what will be his score? Predict the score of a single student. What's average is the best guess, 71. So the point estimates are same. True? This is what we are saying. The point estimates are same for the average for the single value. Then if I tell you, give me an interval estimate for the class average, what will be your interval estimate for the class average? The class average consisting of 34 students, you will say something like 68 to 75%. A very tight interval because this is the average of the class. Some students will be good, some will have a bad score, but the average will be close to 71%, somewhere up and down, but very close to 71%. What if I ask you to give me an interval estimate for the single student? You cannot say 95% confident between 68 and 75. Now, this is a single student. A single student, there is more fluctuation. You will say between, let's say, 40% and 90%. So the interval estimates will naturally be different, but the point estimates will be same, whether you're talking about single value or you're talking about the average value. Yes. For this one, we call it confidence interval, and for this one, we call it prediction interval. For the point, we call it prediction interval. For the mean, we call it confidence interval. This is confidence interval. Confidence interval for mean y when x is x naught. Now, in the previous class, we said that this mu hat of y is beta naught hat plus beta 1 hat times x naught, right? And we said that for the single value, we have nothing available, nothing additional available. So we borrowed that estimate for the single value, and we said this is the same as the average. This is a borrowed estimator. We borrowed it from here. We took it from here as it is. We have the class average. Estimate is 71%. For the single student, we say average is the best guess. We borrow that estimate and put it for the single student also. Now, do you think that the amount of variation in the single student is same as the amount of variation for the average? The answer is no. For the average, there is less variation. For a single student, there is more variation. So we already derived this thing that the variance of this mu hat of y given x naught, this variance is sigma square into 1 over n plus x naught minus x bar whole square over sxx. We replaced sigma square by its estimator. We plugged it into the formula of confidence interval. We already got the confidence interval. But my question is, we already borrowed this estimate. Can we borrow the same variance also? The answer is no, because there is more fluctuation now for the single value. We cannot borrow. The variance of y naught hat will not be the same. It's higher. We know it's higher. It's not the same. And the expression we will derive, it will clearly show you mathematically that it is higher than this one. Always be higher than this one. So where do we estimate the variance of this thing so that we plug it back into the formula and we get the confidence, or we call it prediction interval? The answer is the estimate for the variance of a single value will come from the corresponding error, E naught, which is the actual value minus the predicted value, true? And this actual value for that specific x naught, for specific x naught, there will be a corresponding y naught, which is yet to be observed. You don't know this thing. This is what you know. By putting x naught into the model, you get y naught hat, true? This is what you know. So E naught will come when y naught is observed. It's not there with you yet. So whatever is the variation in this E naught, same will be the variation in y naught hat, because y naught, whatever it will come, it will be a constant value. So adding or subtracting a constant will not affect the variance. So we just apply the variance on this E naught, and the resulting variance comes out to be this one, true? How do we apply the variance? What is variance of x minus y? Variance of x plus variance of y minus 2 times covariance of y naught and y naught hat. Now, as we expect in every single derivation in this course, what happens with the covariance? I'll give you the reason. The reason is, where is this y naught coming from? Let me make a table for you. This is the data, 1, 2, 3, all the way up to n. You have x, you have x1, you have x2, you have x3, all the way up to xn. You have y, you have y1, you have y2, all the way up to yn. You use this table, right? And some extra columns, x square, xy, you get sxy, syy, and you get b naught, b1. You use this table and you get this equation. True? You get this equation. Then in future, there is x naught and there is y naught, which is yet to be observed. You are saying if x naught is this, what will be y naught? This is yet to be observed, right? Now, if you plug this value of x into the model, what will you get? You'll get the predicted value of y. Actual is yet to be observed. This is yet to be observed. Actual of x, you know it. Yes, which is x naught. You're trying to say that if I put this much chemical, how much output will be produced? So you know how much chemical you have to put. X naught is, you know it. You are the one controlling x naught. Now, the point here is where is y naught hat coming from? Is it coming from in the whole calculation of y naught hat? Am I using y naught? It's coming from this half of the table. And of course, this x naught. Nowhere it is using y naught, right? Can you tell me before observing y naught, will it be above y naught hat or below y naught hat? You can't. Will it be close to y naught hat or far from y naught hat? You don't know. There is no relationship between y naught and y naught hat. And when there is no relationship, what does that mean? Covariance will be 0. Throughout this calculation procedure, you see the calculation of y naught hat is nowhere dependent upon y naught. Nowhere it is using y naught. And that is why this covariance will be 0. Now, what is variance of y? Sigma square. Variance of epsilon is sigma square. Variance of y is same sigma square because we're assuming the other part to be constant. Plus this variance of y naught hat or mu hat we derived it last time. It was sigma square times we derived it last time to be this. So if you add the two of them, what do you get? You get this? And you plug it into the prediction interval, what do you get? Instead of sigma square, I will obviously put the you get this. Now compare this whole thing with, where is it? This thing. Because of the one. What just happened? Why its size is big? Just compare the two of them. Yes.
How did you come up with the new variance?
Which variance?
This one, the sigma square, and you add the
Variance for the single value of y is this. And this one, we derived it in our previous class to be this. This is the variance of the error, and we are saying that this should be the right estimate for the variance of single observation and not this one. Not this one. We said this one is true for the average, not for the single value. For the single value, the true variance should be the one corresponding to the error, because error is the term that is differentiating the line from the point. Epsilon is the thing that is differentiating from the line to the point. If you take the equation of the line is here. Look, equation of the line is second. What's the difference between the equation of the line and the point? Epsilon is the difference. So we take help from the epsilon to get the true variance of that term. So this is what we have already seen in the formula sheets or in the previous course, whatever you have taken, you have seen these two intervals. You call this one to be the prediction interval, true? The first one. And you call this one to be the confidence interval.
That's the variance.
Ah. So I'll give you two statements now, and I'll see how do you identify which confidence interval to apply. And I'll use the confidence interval word confidence interval for both of them. I'll not use the prediction interval. This is the first question. This is the second question. What do you apply on first one and second one? First one is prediction interval because you're talking about R propellant, single propellant. And the second one you're talking about, you see the word S and you see the word R. All the propellants. No. You will not see this term in the literature. This one is called prediction interval in the literature. It is like, you know, it is like this thing in literature, we usually denote it by T, and this thing we usually denote it by Z. It's not a rule, but it's a practice. You cannot switch them. You cannot call the first one to be T and second, it will be conflicting most of the books. So it's a well-known notation or terminology that is used. So we will continue to use this one. But again, it's not a rule. It's just the terminology that is used. Okay, any questions until this point? I suppose you can implement this thing in Excel fairly easily. It's just 1 plus something, so you don't have to do anything extra. The same interval, but with 1 plus. Any question? Yes.
That variance is actually similar to the variance of the
It is. It is. In fact, it's like you don't have x naught here in beta naught.
What did we get the
Do we get the
mu?
mu? Which mu? Yeah, this one. Where is it? This one? This one? Look at the top. Plug the value into the model, you will get mu hat. So to construct the confidence interval, obviously the question is, where do we get the point estimate? Before constructing the interval estimate, you do find the point estimate.
It's the same as the things.
It's the same as the point estimate for the average or the point estimate for single value. They are same, exactly the same. Any other questions? Final topic of this chapter is some properties of OLS estimators. What is OLS? Ordinary least square. These are OLS estimators. The first property is that if you obtain the sum of errors from OLS, the answer is always 0. How do you prove it? The sum of residuals obtained from OLS estimators is always 0.
Square errors. This is the assumption that all this is based on.
Also by argument and also by mathematically you can prove it. EI is what? Yi minus Yi hat. True. And what is Yi hat? It's beta naught hat minus beta 1 hat times xi. Y bar minus beta 1 hat times x bar. Let's put that one since you asked it. Beta naught hat is y bar plus, it will become plus beta 1 hat times x bar. So now we have only beta 1 hat in the equation, no beta naught. Let me apply the summation now. How does the summation apply? Now summation is what? Over the sample. Is it over the population or sample? It's over the sample. We are claiming that the sum of residuals over the sample will be 0. So the summation is over the sample. Is Yi changing in the sample? Summation will be applied. It is changing. For the sample, there are n values of Y. They are changing. So summation will be applied on Yi. Instead of Y? No. The expectations are equal. The values are not equal. You expect them to be equal, but they are not always equal. You expect the class average to be 71. You expect the student to be at 71, but when you observe them, are they equal? They are not equal. You expect them to be equal, but they are not actually equal. The mean, the expectation is the mean. The means are equal, but the values, all the values are not equal. Y bar is the mean of Y for the sample. Does it change for the sample? It doesn't change. So summation will not be applied. It will be n times the constant. y bar, when yi is changing in this table, where is the table? In this table, when I is changing, is the value of y bar changing? It's not changing. For whole sample, y bar is a constant value. It's not changing. So it will not make a difference. It will be n times the constant. X bar, is it changing? Beta 1 hat, is it changing? No, it's calculated from the whole sample. So this whole quantity is not changing. It will be n times. No. Let me write this thing. Let me take beta 1 hat common from this one. Or let's continue. It's okay. N times beta 1 hat times x bar minus beta 1 hat. Is it changing? No, it's a constant. X, is it changing? It is changing. So summation will be applied only on x. Clear? What is x bar? What is y bar? So let us put those two. So I just put x bar and y bar. What happens? N cancels out, and look at these two terms. And look at these two terms. You get what? 0 plus 0, which proves that summation EI, as long as you are estimating EIs from OLS, they are 0. Always 0. This is one property of OLS estimation. The second property of OLS estimation is that the sum of predicted Ys is always equal to the sum of actual Ys. This is straightforward, very straightforward. How do you prove it? Use property number 1. In property number 1, what did you prove? You proved that summation EI, which is a summation of yi minus summation of yi hat, this is equal to 0. You already proved it. Straightforward. The third property. What is the third property? There are 6 and I got stuck at third. Imagine. No, I don't expect anyone to memorize. I expect you to prove. Where are the properties? OLS estimation, properties of OLS estimation. No, that's not the property. That's a supplementary concept that we used. The properties are here. Summation, the third one is that it passes through the line. The line passes through the point x bar, y bar. How do we prove this thing? The fitted line. What is the fitted line? The fitted line is beta naught hat plus beta 1 hat xi always passes through the point x bar, y bar. Do you understand this property? What are they saying in this property? That if you draw the scatter plot, let me explain it to you. If you draw the scatter plot, this is scatter plot, right? Let's say this is the scatter plot. In this scatter plot, the x is ranging from this value to this value. You get that point? if you only look at the x coordinates of these points and take the average of x, the average of x will be somewhere here. True? Also for y, the y's are ranging from this value to this value somewhere. And if you only look at the y coordinates of the points, the average of the y will be somewhere here in the middle. True? You take this x coordinate and you take this y coordinate and draw a point where this is x bar and y bar point on the two-dimensional axis. This point is x bar, y bar, right? This is a two-dimensional plot where there will be a point x bar, y bar. The property says that the line always passes through this point. It never misses this point. It's never above the point, it's never below the point, it's never to the left of the point, never to the right of the point. It always passes through the point. How do you prove this property? Yes.
Using the mean value here,
Using the, what is the mean value theorem? First tell us.
function is continuous, we must respect the R.
It is long time since I looked at 101. What was the mean value theorem? It's more than 10 years. The mean value theorem, what was it again?
Average. 1 over p minus a times the integral from a to b of the function equals the average.
I think you are probably correct. I think you are probably correct. I got an easier way to prove it, but I think you are probably correct. You can prove it through the mean value theorem. Now, the easiest way or the simple way is to what? You put the x coordinate into the equation. As a result, if you get the y coordinate, the point always lies on the line. What did I say? You put the x coordinate into the line. As a result, if you get the y coordinate, that means the point is on the line. How do I check that this line is passing through 3, 9? If I put 3 in the line and I get 9 as a result, that means the point 39 is on the line. True? So put x bar into the line, and if you get y bar as a result, the point is on the line. Do it. X bar, you don't know x bar. Whatever is the x bar of the sample, just put it inside. This is the line. Just put x bar instead of x. As an input, just put it x bar and solve it. If you get y bar, this x bar, y bar is on the line.
That's y minus y bar equals y.
yi minus y bar is not equal to xi minus x bar. No, it's not. It's beta naught plus beta 1 times xi minus x bar. Okay, last thing. Just put this into the equation. What do you get? You get beta naught hat plus beta 1 hat times x bar. Solve it. What is beta naught hat? This is beta naught hat, right? Which is y bar minus beta 1 hat times x bar, right? So these two cancel out. What do you get? As a result, you get y bar, which means that this point x bar, y bar is always on the line. You put the x coordinate into the line gives you output as the y coordinate. This point is always onto the line. The remaining three properties are summation xi is always 0. We proved that the sum of errors are 0. The weighted sum of errors is also 0 if the weights are xi's. And the weighted sum is also 0 if the weights are the predicted values.
We already have an assignment.
This is
Previous one.
vacations gift.
We already have it before the vacation.
That's expiring today.
No.
Is it? When is it expiring?
You did
It's
not-
expiring soon.
You did not publish it.
It's expiring soon. Yeah. So this one, let's give it up to Saturday.
So we don't have it by the-
No, Saturday by the end of the weekend. What is the date? 1st October? Sure.
Yes. The assignments we don't have it in Blackboard, you know.
I will just keep solving them. When I publish them on the Blackboard, upload it.
The previous one.
I
The
know
notes?
the deadline is not gone yet, right?
So you have it in the notes.
Yes, one note. Yes, it is. Just keep doing them on the paper, and once I publish them on the Blackboard, just take a snapshot. And now, week 7, which is week 7? Let me tell you the dates. We are in week 5 now. 6 will be from 2 to 7, and week 7 will be from 9th of October all the way up to 15th of October, excluding 14th. We can have exam on 15th, Saturday, no problem. I'm available. From 9 to 15, any day, any time. Let me know. Where all of you, all 34 of you can agree on a single date and a single time. From 9 all the way up to 15. Once you are done, I'll give you 3 to 4 days maximum up to Tuesday. Let me know. Once you are done, let me know the time and the date, and I will publish this poll on Blackboard. All 34 of you have to agree to that. If you don't agree to that, if a single student, and I will not tell who disagreed. If a single student disagrees, I will give you the date and time, and nobody will object to that. I'm giving you the chance. I'm giving you 2 days to decide among yourselves. Okay? So by Tuesday, let me know.
Can never be in weekends. Can never be on weekends.
Weekend, no problem. For me, no problem.
But if you choose a week 8 and then,
No, I'll not choose week 8. I'll choose week 7.
oh, but we can agree on weekends.
Yes, you can agree from 9 to 15, any time, any day.
No, week 8.
No week 8, 9 to 15.
Have to be football.